And this says the graphing equation is given. List the intercepts on the graph. Based on the graph, tell whether it is symmetric with respect to the x-axis, the y-axis, or the origin, or nothing. This guy should remind you of the exponential function, like e to the x. Looks a lot like that. 2 to the x. Don't know what it is. So, does it have any x-intercepts? None. No, none. Does it have y-intercepts? 1. And it's, what is a coordinate point? 0, 1. And what about symmetry? Folded across the y-axis? No. Folded across the x-axis? No. Origin means I'd pick a point here and move it. There should be a mate down there, is it? No. So is it symmetric with respect to? No. Now this should remind you of the quadratic, right? Like x squared. In this case, it might be, and I can't say for sure that it is, something like x squared minus 3. So I take a look at it. What about x-intercepts? Yeah, it looks like here and here, right? So this would be -3 or -2, 0, and 2, 0. Y-intercept? 0, -3. What about symmetry? Yes, to what? The y-axis. You can fold it, you can see it folded across the y-axis. This goes up through the middle. This guy and those two are images of each other. You fold it, they would lie on top of each other. So this would be y-axis. What about that guy? X-intercept? Yeah, right there. And that would be what? -2, 0, and 2, 0. Y-intercepts? That would be here. And that would be what? Okay, 0, 2, and 0, -2. Symmetry? To what? Okay, if I think about x-axis, is the mirror image of that top at the bottom. Yep. So it's origin, it's x-axis.
Would be all 3.
Yeah. And if I look, is the image of that guy there? Yes. Y-axis. And if I look at this, here's this piece, is his image across. Yeah, so origin. So he's symmetric to all 3. Circles are, because circles are nice. Well, sometimes nice. Not all the time.